All right, so in this example, we're actually going to take a look at two different synchronization primitives instead of one, but they're so similar that I've sort of lumped them together. And those are ManualResetEventSlim and AutoResetEvent. So as you can probably remember, in both the countdown event and in the barrier, we had a counter. We had a number. Now in the reset event is just a single event. So instead of a counter, you basically have a counter counting up to 1. That's the difference. And so you set the signal in one location and you can wait on it in another location. Let me put together a very quick example. So what you would use is something like a new ManualResetEventSlim. Once again, Slim is an improvement upon the original reset event. So you would make one. You can also set the initial state of the event, whether there is a signal there or not. So we're going to avoid it by just setting it to false. And then you can actually, for example, let's have a task where we're once again going to simulate boiling water, and then in another location we're going to be waiting for this water. So first of all, I'll do task.factory.startNew, and here all I'm going to do is I'm going to write line boiling water, and essentially let us suppose that there is some other task which is waiting on this task. So there's going to be make t, once again task.factory.startNew, and here I'm going to wait until the water is finished. Now we can do this using continuations, that's very easy, but instead we're going to use a manual reset event, and this basically is just a signal that we can continue. So here we can specify that we are in fact ready to continue by calling evt.set. That sets the signal, and then here we can wait for the signal. So we can first of all write line that we're waiting for water, and then we can wait for the signal, evt.wait. By the way, look at the overloads here. Once again, you have cancellation token, you have a time span timeout, and you also have both of them in one of these. So we wait for the event, and then we can write line, for example, here is your t. So this is a very simple example. We can just make t.wait here to wait on this to execute, and as I run this, we are waiting for the water, but then we boil the water, so here is your tea, you can now drink it. So essentially, if in the previous examples you can think of some counter reaching a particular value, here it's like a 0 or a 1, so this would essentially set it to a 1, and this would wait until it's a 1, and when it is a 1, it will unblock and let you execute whatever's down below. Now there is also, as I mentioned, an auto reset event. So what is the difference between the two? Well, the difference is that if you do a manual reset event, after you perform the wait, the signal is set, and it will always be set, which means that if you do a wait or any number of waits here, everything is going to be just fine because the signal has already been set. So you're waiting for the event, and this event has already been signaled, so there is nothing to wait on effectively. Now the difference is that if you change this to an auto reset event, what would happen at this location, and instead of wait, by the way, there is a different kind of idea here. Let me actually specify. So you have to specify the initial state here in the constructor. That's one difference. And the second difference is that instead of a wait, there is a wait one. So essentially you can see that it's a slightly different function. It returns a boolean as well. It returns whether or not you manage to actually wait on this event. If we leave it with the default values like so, this will essentially hang forever. So let me explain to you why that is. So we have an auto reset event, and initially it's false. You can see that I provided it in the constructor argument. So it's false when we come into here. It's still false here. However, so let me actually put this down. So it's false here. However, we reach this point on a separate thread and we set the event to true. So now that it's true, we can execute whatever comes after wait one. However, this is an automatic event, and what this means is that as soon as it's done waiting, it sets it back to false again. So we set it to true here, but then we set it to false as soon as we go into here. And this means that if we come into here, the thing is false. There is nothing anywhere to signal to us that we can continue. And so we're going to be stuck here. So how can we avoid being stuck? Well, one of the ways is to use those overloads. So for example, we can wait for exactly 1 second, and we can get the Boolean indicating whether we did in fact succeed waiting, and then we can check it. So if it's okay, then we can write line enjoy your tea. Otherwise, if we timed out or if something went wrong, we can write line no tea for you. And of course here, because there is nowhere that we are setting the event, this means that we're going to execute this no tea for you. So let's take a look at what we get. And this is exactly what we get, no tea for you, because essentially as we get here, there's nobody to signal on the automatic reset event. So that's why we fail. Of course, if it was a manual reset event slim, then what would happen as we kind of, well, we can't actually create an equivalent, but we can call wait here. So as we would wait here, we would signal the event. So we would set it to true. It would never turn to false as we exit. So it would still be true here. And when we execute the whole thing, you can enjoy your tea because the invocation has succeeded. So in fact, the name wait1 in the automatic reset event kind of gives you a hint as to the fact that you're only waiting for the signal to turn green once, so to speak. You're not waiting it to kind of be turned on forever. It's only for one time that you can check it. And after you've checked it, it's going to turn back to false and you have to check it again. So that's something